In this video, I'm going to show you how to do a numerical derivative using your calculator. So this is going to be a way to calculate a definite integral of a curve that you don't necessarily know how to take the antiderivative of analytically. You can use your graphing calculator to approximate the value of this integral. So first, let's go ahead and graph a function. So maybe we'll go sine of x squared. So this takes a little bit more work to take the antiderivative of analytically. Maybe we'll zoom standard, take a look at what that looks like. Kind of crazy. Maybe let's calculate this integral from 0 to 2. So let's just adjust our window here. Maybe we'll look at it from 0 to pi. I know 2 is less than pi. So from 0 to pi, maybe we'll go by pi over 2 for our little subintervals. It's a sine function, so I know it's not going to be any bigger or smaller than 1 and -1, so I'll just go from 2 to -2. Take a look at that. Okay, so there's our sine of x squared graphed from 0 to 2, or sorry, 0 to pi, and it's pi over 2 are our subintervals. We want to calculate the integral of this from 0 to 2, so it's like somewhere over here. Remember, integrals represent the area under a curve. And so if you want to try and calculate that area, we can do that using our graphing calculator. So once you've graphed it and you're in this graph mode, you can hit second trace to go into the calculate options. We're calculating a definite integral, so this is option number 7. And when it's saying your lower limit, that's your lower limit of integration. So we're going to start at 0, and we want to integrate up to 2. So hit 2, hit enter. What's kind of nice is it does shade in the region that you are trying to find the area of, so you can see that it's going from 0 to 2, and then this is the value of your integral here. Now again, this is an approximation because it's not using analytic methods to take the antiderivative, so this is a decimal approximation for that. So this is one way. Now let's say you wanted to take this function and calculate a new integral. Maybe you wanted to just go from 0 to 1. If you go second trace and you want to calculate that integral, same process, starting at 0, finishing at 1. Now, one thing to note is it's not going to look like it shades in this region because the shaded region was already shaded by the previous integral. So if you don't want that to be there, like if you have to do subsequent integrals, you need to clear out that original shading, and the way that you do that is you go into second program, into the draw options, and you want to clear draw. So now you have a fresh, clean window to work with, and you can calculate your integral from 0 to 1 there, right? So that's how you would do this in the graphing window. I want to show you how to do it from the home screen. So if you're here in the home screen, you can calculate the numerical derivative from the math options. So click math, and under the math tab, it's this option here, 9, the FNINT, so that's our numerical derivative. And then it just gives you basically what looks like a definite integral. So you go 0, you go to 2, type in your function here, so it was sine of x squared, close off your parentheses, tell it the variable you're integrating with respect to, hit enter, boom, we get the same result. Now, one thing that's kind of nice is when you're doing this this antiderivative using this method, we already typed this function in our y1, and so if it was some like crazy long function and you didn't want to have to type it all out again, you could actually utilize it being stored in y1 when calculating your integral. So let me show you that. So let's bring up our numeric integral here again. Our limits of integration are still the same, but instead of having to like type out our function, we want to basically recall the function that's stored in y1. So there's two ways you can access this. So in like the newer operating systems of like the TI-84 and 84 Plus, you can use your alpha menus. So you can go alpha trace, and it'll bring up your y1s, and then you would just like your y variables, and you can just recall y1. Remember, we wrote that as a function of x, and boom, there you go. Now let's say you wanted to access it a different way. You can click on the vars button, the variable button, we want to scroll over to the y variables and choose function and then y1. So again, that would allow us to do that. And actually, from your alpha menus, you can access this integral. If you go alpha, I think window, alpha window, that will bring up some kind of nice tools. So absolute value, summations, derivatives, integrals, logs with not base n or base e or 10. So you can use those, and it would be option 4 from there. Okay. Now, if you have one of the older operating systems, like a TI-83 or something, I want to show you just quickly what the key presses will look like in that. So if you go to type your numeric integral, you would still access it from the math menu. Unfortunately, you don't have the alpha menus. This is kind of the order that you need to type things in. So first you type in your expression, so it'd be sine of x squared, close off your parentheses. Then you're going to put a comma, and it's saying what is your variable of integration. So that's with respect to x, and then you put your lower limit of integration, comma, upper limit of integration, close your parentheses, and then when you hit enter, it would calculate the integral for you. Now, if I hit enter, it throws it into this format because it does have that updated operating system. But I just wanted to give you this kind of quick tutorial on how to evaluate a definite integral using your graphing calculator. Hopefully it helps.